Hey guys, so we're going to look at chapter 8 today. Okay, so 8-1, the objectives, we can identify key features of the graph of the quadratic parent function. Okay, so 8-1, key features of a quadratic function. Alright, so what is a quadratic parent function and what are the characteristics? Well, the quadratic parent function is f of x, or y, equals x squared. Okay, this is the simplest function in the quadratic family. Okay, and we call this function a parabola. Okay, the graph is going to be called a parabola. Okay, so again, parent function is the simplest function in that type. Okay, so if I'm talking about linear functions, the simplest linear function is y equals x. Okay, so the simplest quadratic is y equals x squared. Okay, so y equals x squared. Here is a table of the values. Okay, notice they use -2 to +2, just like we did when we did exponential functions. Okay, so when I plug in -2, I get 4. -1, I get 1. Okay, right? -2 squared is a +4. -1 squared is 1. I plug in 0. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay, so we have this list of values. Okay, so if I graph those points, it looks like this. Okay, this is called a parabola. It makes a U shape. Okay, an important point on a parabola is called the vertex. Okay, the vertex is where I switch directions. Okay, so our vertex here is 0, 0. Okay, the vertex is the lowest or the highest point of the graph of a quadratic function. Okay, it's also called the turning point because, again, this is where I switch directions. Okay, so down, see here, I'm going down. Hit this point, boom, I'm going back up. Okay, we also have another characteristic is called the axis of symmetry. Okay, the axis of symmetry is the equation x equals 0. Well, x equals 0, that's just a Vux line. Okay, so x equals 0 looks like this. Okay, that's my axis of symmetry. Okay, notice if I fold that parabola in half, it's reflected perfectly on the other side. Okay, it's symmetrical about this line. Okay, notice this point is 2 spots away. This point is 2 spots away. Okay, so it's symmetrical. The axis of symmetry intersects the vertex and divides the parabola in half. Okay, another important characteristic is we need to decide what direction the parabola opens. Okay, if I'm looking here, it opens up. Okay, so those are some important characteristics: the vertex, the axis of symmetry, and the direction it opens. All right, so let's look at this one. We want to know when the values of f of x are positive and when they're negative. Well, remember, f of x is just the same thing as y. Okay, so where are my y's positive and where are my y's negative? Well, f of x is positive everywhere. Okay, we don't have any negative y values. Okay, f of x is positive for all values of x. Okay, f of x is never negative. Okay, at least in this example. Okay, so let's throw a number into this equation. Okay, instead of having just y equals x squared, let's put a number in front of the x squared. Let's see what happens. Okay, so if I have y equals a times x squared, okay, and I'm going to add a slider so I can play with it. Okay, this is our normal parent function right here. Okay, this is just what it normally looks like. Okay, so we'll see what happens when I play with a. Okay, notice a is getting bigger. Oh, my parabola is getting a lot skinnier. Okay, if I go between 0 and 1, okay, look, it's getting wider. Okay, notice my parabola is getting wider. Okay, so when a is between 0 and 1, okay, so basically think of it as a fraction between 0 and 1, our parabola is wider. Okay, when our absolute value of a is greater than 1, the shape of the parabola is skinnier. Okay, think back all the way to chapter 3, okay, when we did the transformations of a linear function. Putting a number out in front of the function makes it skinnier or fatter. Okay, so if it's a fraction between 0 and 1, it's much, much wider. Okay, if it's greater than 1, it is skinnier. Okay, and it doesn't matter if a is positive or negative, it's still going to happen just the same. Okay, let's see what happens when we make a negative. Okay, so again, notice we're still facing up when A is positive. Oh, A flipped to negative. Look, my parabola is upside down. Okay, so when A is positive, we face up. When A is negative, we face down. Okay, so when A is greater than 0, the parabola opens up. When A is less than 0, the parabola opens down. Okay, it doesn't matter if it's opening down or up, we still can get skinnier and wider. Okay, so how does the sign of A affect the domain and range of f of x equals ax squared? Well, the domain is always all real numbers. Okay, we can pick any x we want and plug it in. The range is what gets interesting. Okay, when A is greater than 0, my range is y is greater than or equal to 0. When A is negative, our range is less than or equal to 0. Okay. So this basically means it's opening down, so I can go from negative infinity all the way up to 0. Okay, and then up here, I have no negative, so I'm 0 all the way up to positive infinity. Okay, so that's our domain and range. Right, so now we need to decide over what interval is f of x equals 4x squared increasing and when is it decreasing. I think this is the easiest to see when you're graphing it. Okay, so they say make a table of the values and then go ahead and graph. So let's go ahead and do that. Okay, so we're going to use the values from -2 to +2, just again because it's centered around 0 and it usually allows you to see the entire parabola. Okay, so let's plug these into y equals 4x squared. So if I plug in -2, I'm going to do 4 times -2 squared. Well, order of operations, we start with the exponents. So this is just 4 times, let's see, -2 squared. That means -2 times -2, so that's a +4. Okay, so this is 16. Okay, let's plug in -1. Well, -1 squared is just 1, so 4 times 1 is 4. Now let's plug in 0. 4 times 0 squared is just 4 times 0, which is 0. Okay, 4 times 1 squared is 4 times 1. And 4 times 2 squared is 4 times 4, or 16. Okay, so let's go ahead and graph it and see what happens. If I throw my graph in here, let me get a little smaller so we can actually play with the whole thing. Okay, if I plot -216, that's off the graph. I don't want to plot him. Okay, so let's plot -1, 4. So -1, 1, 2, 3, 4. 0, 0, okay, and then 1, 4. And again, 2 is just off the graph, probably about up here. Okay, so if I connect my dots, okay, not a very good job, but that's okay. Okay, notice I have a very skinny parabola here. Okay, so let's go back to the questions. Okay, over what interval is f of x increasing and when is it decreasing? Okay, so think of it in terms of slope. When do I have a positive slope? When do I have a negative slope? Well, from -infinity to 0, I'm decreasing. Okay, so when x is less than 0, f of x is decreasing, okay, because it has a negative slope. Okay, and then it's increasing once I hit 0 and keep going. So when x is greater than 0, that means f of x is increasing. Okay, I have a positive slope. And again, notice right when I hit that vertex, I switch directions. Oops, sorry, went wrong way. Oh yeah, so let's look at a word problem. The owner of a new dance studio is installing wooden floors in all of the dance rooms. How much should the owner expect to spend on flooring for a square room with 15-foot side lengths? Okay, well, I gotta figure out, oh, this is the area. Okay, so how do I find the area of a square? Well, area is equal to side squared. Okay, but I want to know the charge per square foot. So wouldn't I need to take my area times 875? Okay, so let's plug in some numbers. So what is my side? Well, my side is 15. So the money I'm going to pay is 875 times 15 squared. So in your calculator, 875 times 15 squared is 225. You're going to get $1,968.75. So that is how much this owner will pay for this room. Okay, last example we're going to look at, last type of problem. We're going to compare the average rates of change for f of x equals 0.75x squared and g of x equals 1.5x squared over the interval from 2 to 4. Oh, remember these? Average rate of change. That means slope. Okay, so not a hard problem, but there's going to be a lot to do. So let's start with f of x. Okay, I'm going to plug in 2. So the first thing I'm going to do is plug in 2. So 0.75 times 2 squared. Okay, 0.75 times 4 is equal to 3. So I get the 0.23. Okay, I'm also going to plug in 4. Okay, so okay, so 0.75 times 16, well, that equals 12. So I have the other point is 412. Okay, because I plugged in 4, I got out 12. So now I've got 2 points. Let's find the slope. So remember slope formula, y2 minus y1 over x2 minus x1. Okay, so here's x1, y1, x2, y2. Okay, we should be pros at this by now. So 12 minus 3 over 4 minus 2. Okay, well 12 minus 3 is equal to 9 over 2, which equals 4.5. Okay, so this one has a slope of 4.5. Okay, let's do our other problem. Okay, we have f of x is equal to 1.5 x squared. Okay, so again, I'm plugging in 2. So 1.5 times 2 squared is just 1.5 times 4. So 1.5 of 4 is equal to 6. So the first point I get is 2 comma 6. And we're going to do the same thing with 4. So 1.5 times 4 squared is just 1.5 times 16. Well, 1.5 of 16 is equal to 24. So the other point I get is 424. And again, now we need to find slope. Okay, so m equals y2, so 24, minus y1 is 6, over 4 minus 2. 24 minus 6 is 18, over 2 equals 9. So what can we say about these slopes? Okay, the slope for g of x is double the slope for f of x. Okay, so this slope is much, much steeper than this slope would be. Okay, one more. You try this one, and then I'll go ahead and do it after you try this. So pause the video and try this problem, please. Okay, so we're plugging in -5. So if I plug in -5, so 0.5 times -5 squared, well, -5 squared is a positive 25, and that would be negative 12.5. So the first point I get is -5, negative 12.5. And now I'm going to plug in -2. Okay, -2 squared is 4, so that is going to be -2. So I get the point, -2, -2. Now I can do my slope. Okay, so m equals y2, so -2 minus negative 12.5 over -2 minus negative 5. Well, remember, anytime we have minus negative, it turns into plus a positive, so this gives me 10.5 over 3. And 10.5 over 3 is just 3.5. Okay, one more time. Okay, let's plug in negative 5. So negative 1.5 times negative 5 squared. Well, it's negative 1.5 times 25. 25 times negative 1.5 is going to be negative 37.5. Okay, so this gives me the ordered pair, negative 5, negative 37.5. Okay, round 2, do it this time with negative 2. Okay, so negative 1.5 times negative 2 squared. Well, it's negative 1.5 times 4, which is equal to negative 6. So I get the ordered pair, negative 2, negative 6. Okay, so again, we're going to do slope. I'll do it in black because I need a different color. So m equals negative 6 minus negative 37.5 divided by negative 2 minus negative 5. Negative 6 minus negative 37.5 gives me a little bit more room. 31.5 over a positive 3 gives me 10.5. Okay, so g of x has a much steeper slope. Okay, so again, remember, minimum or maximum. Okay, so this would be called a minimum because it's the lowest point in that vertex. This one would be a maximum because it's the highest point. Okay, vertex is important, axis of symmetry is important, which way it opens is important. Okay, so homework tonight, you're going to be on page 320. You're going to do problems 11, 12, 15 through 25 odd. Hope you guys have a nice day.